Dear children, welcome to this channel. This is ninth video in the chapter Theory of Equations. So far, we have seen how to frame the equation given the roots by using Vieta's formula, and also what would be the nature of roots and how they occur in the past 8 videos. Okay. Now, in this ninth video, we are going to see there are some techniques to find out the solution of certain polynomial equation. Let us see some techniques to solve polynomial equation other than quadratic equation. Okay. So, for some polynomial equations of higher degree, let us see some techniques to get the solution. If first one is, if some roots of the equation are known, that means they may be either imaginary or irrational or real. Some roots are known, then how to find out the other root means what you have to do, using the roots let us find out the factors. For example, if 7 is a root of the equation means x minus 7 would be a factor. Like that, using the roots find out the factors, right? And then find out the product of the factors. Then divide the polynomial by the product of the factors. So, what happened to the polynomial? It will be reduced to a equation of degree lesser than the given one. Okay. Then by solving the reduced equation, we may get the remaining solution. Okay. So, this is one method to find out the roots of polynomial equation given some roots. Okay. So, by finding out the factor and taking the product and dividing the polynomial by the product, it will be reduced to a equation of lesser degree, and by solving the lesser degree equation, we may get the remaining roots. This is one technique. Okay. Then that is, if we want to explain this, we can see for a quartic polynomial, if one root is an imaginary or it may be either irrational, okay, then you know that for imaginary it will occur in pair, the roots occur in pair. Sometimes for irrational also they will occur in pair, but not for, it will be not true for not all the polynomial, but it's some polynomial equation it will be true. So, let us take that the conjugate will also occur. So, what happened? For you may get a given one root, we may get the other root also by taking its conjugate. Then by multiplying the two factors, you will get a quadratic polynomial. Then dividing this quartic by that quadratic, you will get the resultant as a quadratic polynomial. And then by solving the quadratic, you will get the remaining two solutions. So, this is the way to find out the roots of the equation given some roots. Okay, this is the technique used to find out the roots of a given equation given some roots, right? Then we will see some example problem after explaining all the techniques. Okay, then what would be the second technique means, if the polynomial has only even powers, okay, of degree 2n. So, if the polynomial equation, that is if the polynomial equation has even powers, that means that the coefficient of odd powers are 0, only it will have even powers, x squared, x power 4, x power 6, like that, and it may be of degree 2n, say it is of degree 2n. In such cases, how will you find out the solution? So, what would be the technique to be followed means, replace this x squared by y. Okay, first step is replace x squared by y. So, what would be x power 4? It will be y squared, x power 6 will be y cube, like that it will proceed. And then, so the polynomial equation will be reduced as a polynomial equation in terms of y, and what would be the degree of that reduced equation? It is of degree 2n, means the reduced equation will be of degree n, right? And then you have to solve that equation. So, you will get n solutions and equate each solution to x square. So, thereby equating x square to each solution, you will get 2 solutions. So, equating x square to n solutions, you will have 2n solutions. So, that would be the solutions of the given equation. Okay. So, this will be the technique to solve the equation if it has only even powers. Okay. So, if it has only even powers, right. So, this technique can also be applied to not only the equation, polynomial equation having even powers, but also to polynomial equations of the form a0 plus a1 x power k plus a2 x power 2k plus etc. an x power nk equal to 0. That is, the least power is k, means the other powers are multiples of k. So if for such polynomials also this technique can be applied. Okay, by taking x power k as y, this will be reduced to an equation in y, and then by solving that y and equating to x power k, you will get the solution for the given equation. See, for an example, consider the equation x power 6 minus 5x cube plus 6 is equal to 0. Here the least power is 3 and the other powers are the multiples of 3, right? Okay. So for this such equations also we can use the above technique. So what is the technique? You have to take this least power x cube as y. So what would be the equation will reduce it to y squared minus 5y plus 6 is equal to 0. And this is a quadratic equation in y. If you solve this, you will get two values, and equating each value to x cube, you will get 6 values. Okay. So if equate, let it the values to be y1 and y2 means equating y1 to x cube, you will get 3 values, and equating y2 to x cube, you will get 3 values. So totally you will get 6 values. So this is one of the technique. Okay. Then if the sum of all the coefficients of a polynomial equation is 0, in such cases, that means if a polynomial equation, if the sum of all the coefficients is 0, then how will you get the solution for the polynomial equation? Means for that polynomial equation, 1 will be a solution. For all equations whose sum of the coefficients is 0 means surely 1 will be a root of this polynomial equation. And then 1 will be a solution means x minus 1 will be a factor. So divide that polynomial by x minus 1 so that the resultant will be reduced by a power 1, and then by solving that you will get the remaining solutions. Okay. Mostly this will be used in the cubic equation, right? Now how I am telling this 1 will be a solution means, let us see here. Now if you take a polynomial equation p of x to be, let p of x is equal to a naught plus a1x plus a2x squared plus etc. an x power n is equal to 0 be a polynomial equation of degree n. Then if we substitute x as 1, what happen? A naught, it will become p of 1 is equal to a naught plus a1 plus a2 plus etc. to an. So p of 1 is nothing but a naught plus a1 plus a2 plus etc. to an. That is nothing but sum of all the coefficients. Okay. So if you substitute x as 1, a naught plus a1 plus a2 plus etc. an is nothing but p of 1, which is nothing but sum of all the coefficients. If the sum of all the coefficients is 0 means, then p of 1 is equal to 0. That means that 1 is a root of the given equation p of x. Okay. So that is why if the sum of all the coefficients are 0, then 1 will be a root. So by if 1 is a root means, then dividing x minus 1 will be a factor, and dividing the polynomial by x minus 1, you will get an equation of degree lesser than 1, and then you can solve this to get the other roots. Okay. Then, like this, if the sum of the coefficients of odd and even powers are equal. So for a polynomial equation, if the sum of the coefficients of odd degree and even power are equal, then for that polynomial equation, surely minus 1 will be a root. So as in the above case, plus 1 is a root, here minus 1 will be a root. And then as minus 1 is a root, x plus 1 will be a factor, and divide the polynomial by the factor x plus 1 to reduce it into a polynomial equation of degree lesser than that. And then by solving the reduced equation, you will get the remaining roots. Okay. So if the sum of the coefficients of odd and even powers are equal, minus 1 will be a root of that particular equation, so that we can divide the polynomial by the factor x plus 1, and by solving the reduced equation, we will get the remaining roots. Now let us see how minus 1 will be the root of such polynomial equation. Now let us see how minus 1 will be a root of the equation if the sum of the coefficients of odd and even powers are equal. Okay. So for that, let us consider a polynomial equation. P of x is equal to a naught plus a1x plus a2x squared plus a3x cube plus a4x power 4 equal to 0. That is a quartic polynomial equation. I have taken a quartic polynomial equation. Then what would be p of minus x? Okay, p of minus x will be equal to a naught minus a1x, that is replacing x by minus x, will have minus a1x plus a2x squared, then minus a3x cube plus a4 x power 4 equal to 0. That is p of minus x is equal to 0 will be like this. Okay. Now, for the first polynomial, let it be equation number 1 and this will be equation number 2. For the equation number 1, sum of the coefficients of odd powers is equal to a1 plus a3, right? a1 plus a3. And sum of the coefficients of even powers is equal to a0 plus a2 plus a4, a0 plus a2 plus a4. That is equation for first equation. Okay. Now, given sum of the coefficients of odd powers and sum of the coefficients of even powers are equal for p of x, right? Given sum of the coefficients of odd powers is equal to sum of the coefficients of even powers of the given polynomial p of x is equal to 0. That is a1 plus a3 is equal to a0 plus a2 plus a4. Okay. Now, here let us move this a1 and a3 to opposite side. So, what you will have a0 plus a2 plus a4 minus a1 minus a3 equal to 0. Okay. Now, what is this? These are the coefficients of p of minus x. Okay. So, a0, a2, a4, minus a1 and minus a3. So, these are the coefficients of p of minus x. And what happened to their sum? Their sum is equal to 0. So, by this result, that is, if the sum of all the coefficients of a polynomial equation is 0, one will be a solution. Okay. So, for that result, by using that result, this implies that sum of the coefficients of p of minus x is equal to 0. This implies that 1 is a root of p of minus x is equal to 0. Okay. By using the third result, we can say that 1 is the root of this equation. P of minus x is equal to 0, right. So, 1 is the root means it should satisfy the equation. So, where is the p of equation p of minus x is equal to 0? This is the second equation. In that it satisfies, 1 satisfies that equation. So, this implies that a0 minus a1 into 1, then plus a2 into 1 squared, then minus a3 into 1 cube plus a4 into 1 power 4 is equal to 0, because 1 is a root, so it satisfies the equation. Now, I am going to alter this as a0 plus a1 into minus 1. I am going to move this minus inside. Okay. Then plus a2 into this plus 1 squared also can be written as minus 1 the whole square. And then moving this minus inside, involving this minus inside, what happened? It will be minus 1 the whole cube, because minus 1 the whole cube is also equal to minus 1 cube. So, we can rewrite like this, and this would be plus a power 4 into minus 1 the whole power 4 is equal to 0. So, I have rewritten this equation in this form. So, look at this. This is nothing but p of minus 1 is equal to 0. Okay. P of minus 1 is equal to 0. What is p of x? a0 plus a1x plus a2x squared plus a3x cube plus a4x power 4 equal to 0. Here x has been replaced by minus 1. So, this is nothing but p of minus 1 is equal to 0, which implies that minus 1 is a root of p of x is equal to 0. So, we have proved that minus 1 is the root of the given polynomial equation p of x is equal to 0 by taking the condition that sum of the coefficients of odd powers and sum of the coefficient of even powers are equal. Okay. So, do you understand this? So, if the sum of the coefficients of odd powers and the even powers are equal for a polynomial equation, then minus 1 will be a root for the such polynomial equation. And then, if the roots are in arithmetic progression or geometric progression or harmonic progression, then how will you find out the solution? Okay. So, you have three cases AP, if they are in AP, GP or HP. So first case, if they are in the arithmetic progression. So in the case of arithmetic progression, the roots are in the arithmetic progression. How to take means, if the equation is a cubic one, then you have to take the roots as a minus d, a and a plus d, instead of taking as usual alpha, beta and gamma, okay, because they are in arithmetic progression. So you have to take the roots in such a way that a minus d, a and a plus d, and then you have to proceed to find out the using the sum of the root and the product of the root, you can find out the value of a and d, and hence the solution can be obtained, okay. And similarly, if it is an equation of degree 5, then you have to take the roots as a minus 2d, a minus d, a plus d, a plus 2d, and so on. If it is an equation of degree 4, means you have to take the root as a minus 2d, a minus d, a plus d, a plus 2d, that's all. You shouldn't take a. Likewise, you have to proceed. Similarly, if the roots are in geometric progression, and if the equation is a cubic equation, how to take the root means a by r, a and ar. And if they are of it is of a degree 5, means then the roots should be like this: a by r squared, a by r, ar and ar squared. And then by using sigma 1, sigma 2, sigma 3, we have find out the value of a and r, and then you will get the required roots, okay. Then in the case of harmonic progression, if the roots are in harmonic progression, then the reciprocals will be in arithmetic progression. You know that if if the three numbers are in HP, means then the reciprocals will be in arithmetic progression. Likewise, if the roots are in HP, then the reciprocals will be in AP, and that reciprocal, that values will be the roots of the equation obtained by replacing x by 1 by x. That is, given polynomial equation, you have to replace x by 1 by x. For that equation, this the roots which are in AP will be the roots. So by transforming the equation after replacing x by 1 by x and taking the arithmetic progression roots, we have to take the roots to be a minus d, a and a plus d, and then by solving this we get the value of a and d, and hence we can take the reciprocal to get the required roots, okay. So while doing problems, you may understand the technique, all the techniques. Now shall we see some examples to explain the above techniques, okay. So example 3.15. If 2 plus I and 3 minus root 2 are the roots of the equation x power 6 minus 13 x power 5 plus 62 x power 4 minus 126 x cube plus 65 x squared plus 127 x minus 140 equal to 0. See, given a equation of 6th degree and only two roots are given. So by using these two factors, it may be reduced to an quartic polynomial. And then it will, but if it is reduced to a quadratic, means it would be easy for us to find out the solution. But you know that if one root is conjugate imaginary, then the other root should be, there will be a root of its conjugate. So given 2 plus I is an imaginary root, so this equation must have one root as its conjugate. So you know that by the theorem 2 minus I is also one root. And similarly, 3 minus root 2 is an irrational root, means this equation should have another root as 3 plus root 2. So now you have 4 roots. So by taking the 4 factors and multiplying them and dividing this polynomial by the product of the 2 factors, and then you will get the equation will be reduced to a quadratic polynomial, and it can be easily solved to get the remaining 2 roots, okay. This is the method to solve this problem. So we are going to do this problem using the first technique, right. So, to start with, given the roots 2 plus I and 3 minus root 2 are given the roots, we have 2 minus I and 3 plus root 2 are also roots, okay. Then this implies that x minus of 2 plus I, x minus of 2 minus I, x minus of 3 minus root 2 and x minus of 3 plus root 2 are factors, okay. Given the 2 roots, we have 2 more roots, and then using the 4 roots we have 4 factors, right. Let us multiply the factors now. So x minus 2 plus I is one factor, and another one is x minus of 2 minus I. First let us multiply these two factors, okay. So how we are going to rewrite this factor as, just by multiplying this minus, it will become x minus 2 minus I, and second one will be x minus 2 plus I. So let us group this x minus 2 in both, and then this is of the form a plus b into a minus b. So using the identity a squared minus b squared, it will be x minus 2 the whole squared minus I squared, okay. So expanding x minus 2 the whole squared, it will be x squared plus 4 minus 4x, and I squared being 1, it will become plus 1. So x squared minus 4x plus 5. So this is the product of these two factors, right. Then let us multiply the other two factors. So the third factor is x minus of 3 minus root 2, and the fourth one is x minus of 3 plus root 2, okay. So let us multiply these two factors now. So involving this minus inside, it will become x minus 3 plus root 2, and this will become x minus 3 minus root 2. So here let us group x minus 3, right. So it is again of the form a plus b into a minus b, where a is x minus 3 and b is root 2. So the product is x minus 3 the whole squared minus root 2 the whole squared. So expanding x minus 3 the whole squared, it becomes x squared plus 9 minus 6x, and root 2 square is 2. So x squared minus 6x plus 7. So this is the product of these two factors. So when you multiply this quadratic and this quadratic, that will be the product of all the four factors, okay. So let us multiply x squared minus 4x plus 5 and x squared minus 6x plus 7 to get the product of all the four factors, okay. So multiplying this, first x squared into x squared will be x power 4, then x squared into minus 6x is minus 6x cube, then x squared into 7 plus 7x squared. Then multiplying minus 4x with the x squared, it will become minus 4x cube, then minus 4x into minus 6x is plus 24x squared, then minus 4x into 7 is minus 28x, then 5 into x squared plus 5x squared, 5 into minus 6x is minus 30x, then 5 into 7 is plus 35, okay. So after simplification, it will become x power 4 minus 6 minus 4, that is minus 10x cube, then plus 24 plus 7 plus 5, that is 31 plus 5, 36x squared, then minus 28 minus 30, it will be minus 58x plus 35, okay. So this is the product of the four factors, right. Then given equation is x power 6 minus 13x power 5 plus 62x power 4 minus 126x cube plus 65x squared plus 127x minus 140 equal to 0. Now you have to divide the left hand side of the equation by this product of the factor, okay, in order to get the remaining factor. So dividing x power 6 minus 13x power 5 plus 62x power 4 minus 126x cube plus 65x squared plus 127x minus 140 by x power 4 minus 10x cube plus 36x squared minus 58x plus 35, we will get the other factor, okay. So let us divide this by long division method. So while dividing, we can use the detached coefficient method, okay. Instead of taking along the variables, just we can use the coefficients alone, that is called detached coefficient method. So write down the coefficients of the dividend. that is 1, minus 13, 62, minus 126, 65, 127 and minus 140. Okay, and then write down the coefficients of the divisor. So 1, minus 10, 36, minus 58 and 35. Okay, so this is just instead of writing the variables, if you write the coefficients alone, and this division is called division of the polynomial by detached coefficients. Now to get the quotient, let us divide the first term by first term. So 1 divided by 1 is 1. Then multiply this quotient, that is 1, with all the terms here. So 1 into 1, 1, 1 into minus 10 is minus 10 and 36, minus 58, then plus 35. Now let us subtract this. For to subtract, you have to change the sign. Okay. So after changing the sign and on subtraction, it will get cancelled, and then minus 13 plus 10, it will be minus 3, and then plus 62 minus 36, it will be plus 26. Then minus 126 plus 58, it will be minus 68, and then 65 minus 35 is plus 30. Now let us bring down the next term, 127. To get the next term of the quotient, again divide the first term by first term. So minus 3 divided by 1 is minus 3. Now let us multiply minus 3 throughout here. So minus 3 into minus 10, that is plus 30, and then minus 3 into 36, that is minus 108, then minus 3 into minus 58, which will be 174, then minus 3 into plus 35, that is minus 105. Again changing the sign in order to subtract. Okay, then these 3 get cancelled, and then plus 26 minus 30, it will be minus 4. Then minus plus 108 and minus 68 will be 40, and then minus 174 plus 30 will be minus 144. Then plus 105 and plus 127 will be 232. Then bring down this minus 140. So to get the third term of the quotient, divide the first term by the first term. So on dividing minus 4 divided by 1, it will be minus 4. So again multiplying minus 4 throughout, you will have minus 4, then plus 40, then minus 4 into 36, minus 144, minus 4 into minus 58 is 232, then minus 4 into 35 is minus 140. Then again changing the sign of all the terms, and if you subtract, all the terms will get cancelled and the remainder will be 0. So what is the quotient? Quotient here, these are the coefficients of the quotient. So it will be the constant term, and this will be the x term, and this will be the x square term. So while dividing x power 6 by x power 4, the starting term will be x squared. So this is the coefficient of x squared and x and then constant. Therefore, what is the other factor? So the other factor is x squared minus 3x and minus 4. So you have to factorize this to get the other two roots. So let us factorize this factor. So on after factorization, you will get the factors as x minus 4 into x plus 1. So on equating this to 0, you will get x minus 4 into x plus 1 is equal to 0, which implies that x is equal to 4 or minus 1. So what will be the other two roots? 4 and minus 1. So finally, what are the 6 roots of the equation? The roots of the equation are 2 plus I, 2 minus I, 3 plus root 2, 3 minus root 2, minus 1 and 4.